Hi, welcome to Apsana classes. Today in this class, let us know about equation of temperature coefficients of resistance. So before deriving the equation for the temperature coefficients of resistance, we have to know how um, temperature coefficients affect on a material like metal. Let's for example take a metal, how it's gonna affect metal. So all metal exhibit positive temperature coefficients. What is this positive temperature coefficients? Positive temperature coefficients is nothing but if we increase temperature, if we increase temperature, then resistance will increase. Resistance will increase. So, but this resistance, the increase in resistance is not only just increases with temperature, but it is directly proportional to initial resistance. Directly proportional to initial resistance. And it is also directly proportional to rise in temperature. Rise in temperature. Just a minute. Rise in temperature. So we can know that, for example, take a metal where its initial temperature, like its initial values we can take there, but as we are gonna talk about first initial and then rise now. So first go with initial temperature. Initial temperature having 0 degrees, and also it is having initial resistance R naught. Initial resistance R naught. After some time, what is the time period? Let's take T. Like okay. After some time, we know that after some time what happens? Temperature of course will increase. If the temperature is increased, of course there will be increase in resistance, right? So after some times what happened? T temperature has increased to T degrees. Fine. Then what is initial will be same? No, of course not. It will increase as metals have positive temperature coefficients. So let's say it is RT. So it rises RT. So if you want to know what is the rise in temperature, what we actually do? Final. So this comes under final, na? Final conditions. So final condition minus initial conditions, right? Then what is the rise in temperature? Now let's know the equation for this resistance. Rise. So if we increase temperature, the resistance will increase. Okay, we have increased temperature. Yes, increased from 0 to T degrees. Then what is the resistance? To find that, let's see what is the rise in temperature. So RT minus R naught is the rise in temperature. Sorry, resistance. Rise in resistance. So from the equation, let's see. from the equation, from the initial conditions, what is this? Initial resistance is directly proportional to this rise in resistance, right? So RT minus R naught is directly proportional to initial resistance. What is this initial resistance? R naught. Okay, fine. And still resistance is also, this is increase in resistance is also directly proportional to rise in temperature. What is that rise in temperature? From 0 to T degrees. So final minus initial, T degrees minus T degrees minus 0 degrees, which is T degrees, right? So RT minus R naught is directly proportional to T degrees. So from this it is clear that RT minus R naught is directly proportional to R naught T degrees, right? Now if you want to equate this equation, we have to have it like a proportionality constants. So here the proportionality constants is temperature coefficients. So temperature coefficients is proportionality constants. Here temperature coefficient is constant proportionality, constant of proportionality. Okay, it is indicated with the symbol alpha. So here RT minus R naught is equal to RT minus R naught is equal to equate this, we took constant proportionality of temperature coefficients, which is denoted with alpha. So alpha into R naught T degrees, isn't it? R naught T degrees, right? Alpha R naught T. So if you want to know alpha only, like temperature coefficients of that material, then we can write this is one, okay, is equal to RT minus R naught by R naught T, isn't it? Yes. Then if you want to know RT, let's find, just send this minus R naught to this side. So RT is equal to alpha R naught T minus plus, so here it is minus, so plus R naught. So in both terms we have R naught as common, so just take it, R naught alpha T plus 1. So this is for that final raised resistance. Thank you for watching. Please like, share and subscribe.